Voyager 1's incredible durability is mostly due to its special energy source, as opposed to many spacecraft that use solar arrays, which only work well close to the Sun. Voyager relies on three distinct devices known as radioisotope thermoelectric generators or RTGs. These specialized power units operate by converting thermal energy produced through the radioactive breakdown of plutonium-238 into electrical power. At the time of its departure from Earth in 1977, these RTGs were generating approximately 470 watts, which was sufficient to power multiple standard light bulbs. However, by the year 2023, that energy output had dropped significantly, nearly cut in half, with the spacecraft losing about 4 Ws each year. As the available energy continues to need, those managing the mission are confronted with difficult decisions concerning which instruments and functions are essential and which can no longer be sustained. This situation mirrors a medical triage where choices must be made about which systems must remain online to achieve mission objectives and which ones must be turned off. A notable decision occurred back in 2011 when engineers chose to shut down the heater that kept the ultraviolet spectrometer warm. Surprisingly, the instrument kept functioning despite being exposed to a bone-chilling temperature of 110 to 79 degrees Celsius. Far unusual signals found inside the control room at the Jet Propulsion Laboratory, where the Voyager project is still being actively monitored, colder than it was ever meant to last. Sleek, contemporary digital displays coexist with antiquated machinery from many decades ago, all of which are nevertheless essential for preserving contact with the far-off ship. Some of the current team members were not even born when Voyager was launched, while others have dedicated their entire careers to managing the probe. Many liken their work to caring for a cherished but progressively frail elderly person, appreciating its tenacity while also realizing its vulnerability. In order to maintain its high-gain antenna's proper orientation toward Earth, Voyager 1 must execute a rotation maneuver twice a year. These maneuvers necessitate the use of hydrogen, a limited and irreplaceable propellant. Estimates indicate that there will be enough fuel left to support orientation adjustments until about 2040, though declining electrical power will probably end the mission before then to extend the spacecraft's operational lifespan. Engineers have created ingenious software updates that can travel great interstellar distances. These modifications reduce the number of times the thrusters must fire the Deep Space Network, a collection of massive radio antennas situated in California, Australia, and Spain. Set aside time each day for surveillance in order to intercept these signals, which have traveled for more than 21 hours at light, are quite feeble for the Voyagers. Examining the unexpected, the cosmic background noise is hardly audible above the data speed. With a data transfer rate of just 160 bits per second, infinite decimal, compared to current internet rates, substantial data is extracted from what would otherwise be indistinguishable as static using sophisticated digital filtering and signal processing methods. While the onboard magnetometer detects magnetic fields that exist in the vast spaces between stars, the plasma wave sensor measures electron densities in the interstellar environment, and the cosmic ray detector captures high-energy particles coming from beyond our solar system. Voyager 1 continues to collect and transmit back priceless scientific data. The collective data gathered by these tools provides an unprecedented glimpse into an otherwise inaccessible region, the enormous invisible medium through which our solar system journeys as it orbits the Milky Way. Projections suggest that Voyager will be able to continue transmitting useful data until sometime between 2025 and 2030. Beyond that, the available power will be insufficient to keep both the instruments and communication systems running even when the instruments eventually go silent. The spacecraft will continue drifting through interstellar space, an enduring envoy from Earthbound for the unknown more than 4 decades after its launch, and well beyond the tenure of its original development team. Voyager 1 began sending back data that diverged sharply from expectations. Embedded within its routine telemetry was a peculiar and subtle auditory signature, a soft rhythmic pulse at a low frequency completely unlike anything previously recorded by the plasma wave instrument. This Mysterious hum was restricted to a narrow frequency band and exhibited an oddly consistent pulsing pattern initially detected during a standard scan of the Interstellar Electron Density mission. Engineers were quick to suspect that the anomaly might be a glitch. After all, the probe was functioning far beyond its intended service life using electronics built in the 1970s. Comprehensive. After NASA's official response, diagnostic tests, and careful analysis of data from numerous other onboard sensors, the strange hum continued and was detected by several receivers within NASA's deep space network. Suddenly, what had appeared to be a routine procedure became urgently investigated. Veteran team members pointed out that this odd pattern didn't correspond with any known astrophysical phenomenon, such as solar fluctuation or equipment-related malfunction. Its consistent and structured quality with exact repetition pointed to one of two possibilities: either a naturally occurring phenomenon that hasn't been discovered yet, or something that might have been intentionally created. The mathematical regularity of the signal led to similarities with the first pulsar detections, which were once thought to be communications from extraterrestrial civilizations before being verified as coming from fast-spinning neutron stars. NASA quickly assembled a panel of experts that included data scientists, plasma physicists, and radio astronomers. When the team compared the observed hum to vast databases of known cosmic signals from pulsars, magnetars, and emissions from active galactic nuclei, no records matched the odd sound. What's more puzzling is that the anomaly persisted consistently, ruling out transient cosmic events like supernovas or gamma-ray emissions. The eerie discovery was difficult to ignore. It was as if someone had purposefully knocked in a room that should have been empty. Humanity's furthest traveling spacecraft had entered an enigma. The Explorer had discovered something completely unprecedented, something no one had predicted during its design or launch. Shortly after the discovery of this odd signal, the spacecraft's data revealed another similarly perplexing occurrence. Unexpectedly, Voyager 1 had changed its direction. Logs showed that the thruster had been reoriented subtly without any guidance from Earth. Is there contact with alien beings here? Firings, although Mission Control had not issued any orders. The team first looked into the possibility that a long-forgotten software procedure or perhaps a safety protocol from decades ago might have been activated automatically. They carefully reviewed redundant systems and fail-safes intended to activate in an emergency, but none of them could explain the exact maneuver that was carried out. The thruster activity was not arbitrary either. It followed a calculated sequence that shifted the probe's aim in a deliberate and directed way. Even more curious was the new direction in which Voyager was now pointed. Its camera platform, long since deactivated, had been turned to face an otherwise insignificant portion of the sky devoid of prominent stars, galaxies, or known celestial bodies. The proximity in timing between the appearance of the mysterious hum and this orientation shift raised suspicions that the two might be related. Statistically, it seemed implausible that such anomalies could occur independently. At NASA's Control Center, analysts worked tirelessly, digging through years of trajectory data, system logs, and previous signals in exhaustive detail. The tension in the room was palpable. After ruling out all conventional causes, it became apparent that the orientation change was not an error or momentary deviation. It was real, consistent, and sustained. Whatever had triggered the maneuver had effectively altered Voyager's path through space. As further scrutiny was applied to both the hum and the course correction, researchers discovered a new irregularity embedded in Voyager's radio transmissions: very subtle changes in time and frequency that, when analyzed, created repeated patterns. They weren't random and didn't seem to be the result of interference. Hypotheses for the encounter: when visually represented, the patterns from the interstellar medium resembled geometric shapes and recursive sequences. Some even appeared to be echoes of Voyager's own communication style, as if something were mirroring or imitating its signal. The anomalies were consistent across various transmissions and weren't one-off artifacts. NASA hired artificial intelligence experts and coderickers to use cutting-edge machine learning models and cryptography methods to examine the pattern. The findings were astounding. Parts of the identified pattern resembled parts of the Arecibo message, a deliberate radio broadcast that mankind had sent into space in 1974. The scientific community was split on this. Others emphasized the signal's intricacy and deliberate appearance, contending that it bore characteristics of deliberate design behind closed doors. while others propose that the cause might be a rare cosmic condition, an unusual plasma environment, or a magnetic field configuration impacting Voyager's onboard systems. As hypotheses proliferated, some researchers put forth new frameworks for understanding how deep space environments could cause signal distortions that appear artificially structured, while others, especially in the SETI community, discussed whether this could be the first concrete indication of intelligent contact. While many experts were internally very perplexed that no accepted scientific explanation could adequately account for what they were seeing, NASA maintained a cautious public posture, referring to the results as an unexplained signal under review. The mystery grew into a cooperative international endeavor. Private laboratories and observatories from academic institutions worldwide collaborated to provide data interpretations and analyses. Whatever the final explanation for these anomalies is, unknown natural phenomena, rare system faults, or something far more extraordinary, they are bound to form a historic chapter in humanity's most remarkable space history. What began as an odd blip had evolved into one of the most compelling scientific mysteries in modern history, drawing on disciplines ranging from astrophysics to data theory. Implications for the Deep Space Exploration Mission, a spacecraft originally engineered for a mission lasting a mere 5 years, has continued for almost half a century, dramatically reshaping our understanding of the solar system and beyond. Voyager's prime years revealed volcanic activity on Io, the delicate architecture of Saturn's rings, and an astonishing array of planetary moons. During its extended mission, it became the first man-made object to directly explore the space between stars. Even in its twilight, it continues to send back irreplaceable data from a domain beyond any current technological reach, but Voyager's influence goes deeper than science. The golden record it carries may persist as the longest surviving relic of human civilization, a time capsule that could exist longer than Earth itself. Its famous pale blue dot photograph forever altered our collective perspective, reminding us of our tiny place in the cosmos. The spacecraft, with its vintage technology still functioning at the edge of the solar system, stands as a tribute to the ingenuity and determination of the human spirit. Even if the anomalies ultimately turn out to be mundane, they've already led to advancements in modeling and analysis techniques, and if they truly represent the unprecedented, they may prompt a revision of what we believe to be true about the universe. Either way, the pursuit of knowledge continues, and conclusion and future plans that being the core of exploration, Voyager 1 will continue on its quiet mission across space for almost 40,000 years after its instruments malfunction, drifting within 1.6 light-years of a far-off star. If Gliese 445 escapes a catastrophic hit, it may live in the galaxy for billions of years, possibly far longer than mankind. Its golden record could one day be all that is left of our species. What precisely did Voyager 1 discover there, and why did it change course? We may never know who or what incorporated those patterns into its signal, but by pursuing those answers and tracking this lone spacecraft over unfathomable distances, we reaffirm our unwavering dedication to exploration. The Voyager's legacy serves as a reminder that the universe contains mysteries we've yet to unravel, and the voyage itself is frequently the greatest revelation. Comparing videolytics tools. In brief,